We're starting activity 19 about a concept called geometric mean. Lesson 19-1 is about the right triangle altitude theorem. So you can see that we're going to be working with right triangles, and in them we'll draw an altitude to see what kind of relationships there are. Here's a picture of a right triangle, triangle AEM, where triangle A has the 90-degree angle, and then from vertex A, an altitude is drawn to the hypotenuse of the triangle, touching that triangle at another 90-degree angle here at point N. Notice that when that additional segment is drawn, that the original triangle is separated into two triangles. Each of them are right triangles. The right triangle altitude theorem says that these two new triangles, this small one here and this larger one over here, are similar to each other, and they're similar to the original right triangle. So let's skip down to question 3 and finish this similarity statement. Triangle MAN, that's the small right triangle, is similar to what other triangle? So we could first say triangle AEN. We need to make sure that we have the correct vertices in corresponding positions. For example, angle A in the small triangle is this little skinny acute angle. In triangle AEN, angle E is that skinny acute angle. In turn, this is similar to the original right triangle. So our original right triangle is MEA. Question 4 says, name the type of special segment AN is in relation to the original triangle MAE. AN is called an altitude. It goes from the corner of the triangle to the opposite side, touching that side at a 90-degree angle. So we can fill that in here, altitude. Let's skip to number 7 and do this check your understanding question. There are 3 right triangles in the figure below. Draw each triangle with the right angle in the lower left position. For example, if we were to redraw this triangle here that goes from B to D to C and draw that so that the right angle is in the lower left position, it would look something like this. This would be angle B, this one here would be the C, and this one here would be the D, which has the 90-degree angle box in it, right? It's the D that has the 90-degree angle box. Next, I'm going to pause the video so you can draw the small triangle, again with the right angle in the lower left position, and draw the largest triangle with the right angle in the lower left position. Pictures will look something like this. Pay attention to how you name the angles. In the small triangle, it's ADC, where angle D is the right angle, but in the largest triangle, it's ACB, where C has the 90-degree angle. All 3 of these triangles are similar to each other, and that's what the right triangle altitude theorem says. If you draw in an altitude in a right triangle, for example, this one here, CD, then that splits the original right triangle into 2 more right triangles that are similar to each other and to the original.